Hello class, we're going to be focusing on evaluating sine and cosine today. I know we have here and graphing, but that's not going to happen for now. So just going to remove that and add that for another video later. So let's start by using our unit circle. And here I have mine along an x and y grid. And along this grid we're going to say that we have some angle theta. And we'll say this theta is 30 degrees. Note that 30 degrees can also be rewritten as pi over 6. Now we've already been using sine and cosine to identify the relationship of saying sine of theta is equal to y over r and cosine of theta is x over r. But what if I just simply said for this example, let's say question 1 is what is sine of 30 degrees here. Note that it also can be pi over 6. And what is that equal to? You might say, okay, let's look at a table or let's plug this into our calculator. Regardless, you'll get the same answer, which should be 1/2. So let's focus on that for a moment and pull this triangle out and just look at it from a triangle perspective, saying this is a right triangle, that's your x, this is your y, it has an angle of 30 degrees, and we have our y being 1/2. Why is it 1/2? Because we assume, in this case it's a unit circle, we should say, rather that we know that the unit circle's radius is 1. So let's try to say how we would find cosine now, to find cosine of 30 degrees. And for this one you shouldn't really be using a table or calculator unless you're using it for Pythagorean's theorem, because remember this x squared plus y squared is equal to r squared, and that's how you find the other one. So in this case we have y, we have r, we're looking for x. And I will tell you that this one is root 3 over 2. So with this method being said, I'm going to give you two more problems. Before I do, I'm actually going to move this over and say I don't want that there. Let's just put this on the side so you still use it as reference. But now I'm going to say question 3, what is sine of 150 degrees? And question 4, what is cosine of 11 pi over 6? So at this point, feel free to pause as you try to enter these questions. Just continuing, I notice I did not put this in, but this is the root 3 over 2. And we're going to continue on with the other 3 and 4 and how we're going to do those. So for question 3, we're going to say sine of 150 degrees. Well, 150 degrees is less than 180, but it is in this quadrant 2 area. So this is 150 degrees. And it's less than 180, so this remaining area here, this degree measure, is actually 30 degrees. Now, based on that information alone, I actually already know what the answer is. It should be 1/2. I know, pretty special. So the big thing about this 30 degrees here is actually, this is called and referred to as a reference angle. So let me highlight that and then write this down. Reference angle. And this is referring to this 30 degree measure here. It's called a reference angle because 150 degrees subtracted from 180 leaves this 30 degree measure. Well, we already worked with 30 degrees before. 30 degrees was over here. Since we know that measure for the height here, right, this vertical component is the same on this side as well. It is also going to be 1/2. And if you notice, that's basically from this measure here is always to the x-axis. So since it's always toward the x-axis, if we have some angle measure on this side in quadrant 1, we actually know the magnitude of either the y or x in every other quadrant. So even though it's in quadrant 2 here, quadrant 2 here, we have that the y is going to be the same value, 1/2, but the x value is going to be opposite. So even though we had cosine 30 degrees here, actually sine of 150, and I'll write this in green, so sine, and I'll do comma, cosine of 150 degrees is actually going to be -3/2. And to draw out this triangle, we have the following: 90 degrees, 30 degrees, and this is going to be 1. This is going to be -3/2, and this is going to be 1/2. So in my attempts to try and do this over, I accidentally undid, and now this is saved, and I can't erase everything. Kind of stinks, but we're going to deal with what it is here, and say that 11 pi over 6 starts off in the standard position right here, and ends up going around, and my radii isn't exactly consistent throughout this, but we'll deal, and it ends up around here. Well, again, we might not know what cosine 11 pi over 6 is, but let's see what's remaining. Using the idea of reference angles, we can say measured to the x-axis, and even though it is an upside down triangle, I'll draw it here, even though it's an upside down triangle, we still are always graphing to, or sorry, making a right triangle to the x-axis. So this is our right angle now. This reference angle, now it was 11 pi over 6, so the way you find the reference angle is going to be 2 pi subtracted 11 pi over 6, and you're going to get pi over 6 radians, which actually is the angle of 30 degrees. So, since we know this is 1, that is our radii, well, it should be 1, and actually let me move this over so we have more room to write what our x values are. Oh, that's not going to go well. I'm just going to, I'm just going to erase all that. Hopefully you have it written down. Okay, and in this case, we have our x and y here. Our y is going to be, actually we're not looking for our y right now, we're looking for our cosine. Our cosine we again already have. It's pi over 6, it's 30 degrees. The cosine is square root of 3/2. That hasn't changed. And the y though, this one was 1/2, it's still 1/2, but now it's -1/2 because it's in the negative y-axis region. So this is going to be -1/2. And if I were to ask you, okay, what is sine of 11 pi over 6, you're going to use your reference angles to say that it is indeed -1/2. Sorry for freezing there. I did realize that I made the error over here of this should just be √3/2. See? All better now. So let's go over some key points from that quick lesson, which is whenever you're looking at reference angles, you want to typically, I call it the bow tie method. And the bow tie method is a way of you always drawing to the x-axis. So if I were to start off quadrant 1, go into quadrant 4, continue that, and quadrant 3 to quadrant 2, quadrant 2 to quadrant 3. You always have your right triangles drawn to the x-axis with right angles to the x-axis, and you actually have your angle theta. Your angle theta is your initial angle. The reference angle actually is normally referred to as your Jesus fish alpha. All in all, you can use any mnemonic device you want to use, or any device you want to use to remember that you always draw your right triangles, your reference angles, to the x-axis, but you always need to draw them to the x-axis. Always. I also like to think about that this kind of looks like Spider-Man. Do a little quick, like, do this. Whoop, 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 whoop. Like, not exactly, but you get the picture. Yes, that was me attempting to do the whole sound effect for him web slaying. So on that embarrassing note, let's keep going and say that we have our reference angles listed, and that's how we're going to use them. We have the bow tie method, and we have some major points along the unit circle that we're always going to refer back to. So let's just look at quadrant 1 here and say that we're going to look at a few different ones, and we're going to start off with our next lesson on these, which are the 3 major points. We have a 30 degree, we have a 45 degree, and we have a 60-degree triangle that we're going to use along our circular path. Oh, I was so close there. I'm just going to erase that. Make believe it never happened. And there we go. So that ends our lesson for today. Hope you enjoyed and hope it was helpful to you. And I'll see you all next time.